Okay, in this video, we're going to go over the study guide for the function unit test. The first learning target is I can use function notation to evaluate functions. So function notation is just f of x. So instead of y, we write f of x. Now, notice inside parentheses is our x value. So a shortcut, instead of writing x equals a number, we can write f of a number. So in this case, we're writing f of -3. So you're just rewriting f of x equals the -4 parentheses -3 squared minus 2 parentheses -3 plus 4. Now notice whenever there was an x, I put in -3. Also notice that I use parentheses when substituting. So in your calculator, you're going to put in -4 parentheses -3 squared minus, make sure you use the minus. If you use the negative, the calculator is going to think you want to multiply, and then parentheses -3, and then plus 4. Now notice we have the -3 right here next to the -2. It's no longer in parentheses because the calculator said we don't really need it. So let the calculator decide. So then you are going to get an answer of -26. So if you wrote that as an ordered pair, it would be -3 comma -26. Or sometimes you'll see the shorthand of it, f of -3 equals -26. For number 2, you do the exact same thing. You have f of x equals 3, but instead of x, you're going to write a half minus 2. Put in the calculator, 3 parentheses, control divide 1/2. You have to move the right arrow to make sure the parentheses there, and then the minus 2. So you're going to get -1/2 as an answer. Now you can get, if you want to write it as an ordered pair, it's a half comma -1/2. Or if you wanted to write it in function notation, you can write f of a half equals -1/2. But this answer would be acceptable. For number 3, a lot of you just try to solve it. I was just asking what f of 4 equals 20 represented. So if you put in 4 into the equation, you're going to get 20. But when Ali's cutting his grass, he's not going to ask what 4 is the x and y is the y and 20 is the y. He's going to say, I cut 4 lawns and got $20. So Ali cut 4 lawns and received $20 because you're plugging in your 4 into your x value, and then he got $20. For number 4, it's a little trickier, but it's the same idea as number 3. So I gave you a function f of x equals 9x plus 12.5, representing how much hours students do doing homework. A lot of you get confused with the 2000 to 2010. Honestly, that is just sometimes when you calculate data, you want a certain time stamp, and for this, it was just 2000 to 2010. So where x is the number since 2000, so that's a very important part. So I'm saying x is 2. So you plug it in just like you did. So if you do that, 9 parentheses 2 plus 12.5, you're going to get 30.5. So what does that mean in the solution? They spent about 30.5 hours in 2002 doing homework. Now, some of you are probably wondering, where did I get the 2002 from? If you look, X is 2, and it's saying years since 2000. So 2 years since 2000 is 2002. Now you do the same thing for part B, but instead of 2, we're going to calculate with the number 5. So I'm just going to copy my equation, and instead of 9 times 2, it's going to be 9 times 5. So then 57.5. So since it's 5 years since 2000, we can say 2005. Now for the next part, the next learning, it says I can determine all solutions that make an equation true. For these learning targets, it's I can determine all solutions that make an equation true, and that I can understand that the graph of an equation in two variables is a set of all its solutions plotted on a coordinate plane forming a line. So we really talked about determining if an ordered pair is a solution. So the graphing is just kind of a review from your middle school days. So in class, I asked you to fill in the -2, -1, 0, 1, 2. Then I also asked you to just kind of erase that column because you don't really need it. So it says part A, it says write in function notation. Once again, it's just f of x equals 2x minus 6. Now, these are inputs. And then to get our outputs, you need to actually calculate. So what I'm just going to do is write the shell of the problem, and then I will fill in the x values as we go on. So then my x values go here. Reason why, because we're just evaluating just like our first learning target said to do. So 2 times -2 is -4 minus 6 is -10. Now you can just throw this in the calculator, or you can do order of operations. Notice that I multiplied first and then subtracted. So 2 times -1 is -2, minus 6 is -8. 2 times 0 is 0, take away 6 is -6. 2 times 1 is 2, minus 6 is -4. 2 times 2 is 4, take away 6 is -2. And then just write them in ordered pairs. All right. Now for part C, it's to graph it. You want to make sure that they're in the line. I'm not going to give you a graph that the points are all over the place, like a scatter plot, because I did give you it to be a function. That's why we're allowed to write the f of x. So if your ordered pairs look more like a scatter plot, just take a deep breath, look at where you misplotted, and just erase them. So -2, -10, -1, -8, 0, -6, 1, -4, 2, -2. A few questions that came up today. Should I connect the points? Yes, you should, because I actually gave you a function. So when I give you a function, you can connect the points. All right, for number 6, you're going to do the same exact thing. Scribble out this y column. Don't worry, tomorrow on the test it won't be there. We're going to write this as function notation, just replacing the y with f of x. So negative 3 times negative 2 is 6, plus 2 is 8. So then I have negative 2 comma 8. Negative 3, parentheses, negative 1 plus 2. So that's 3 plus 2 is 5. Negative 3 times 0 plus 2 is 2. Negative 3 times 1 plus 2 is negative 1. Negative 3 times 2 plus 2. So negative 3 times 2 is negative 6, plus 2 is negative 4. So negative 2 up 8, negative 1 up 5, 0 up 2, 1 down 1, and then 2 down 4. Connect the points because I gave you a function. Now for this learning target, I can determine the domain and range of a continuous and discrete relation. You have to be careful here. For this, on a study guide, I actually reminded you to follow the 2 rules. Tomorrow, I won't. You'll just need to know. So rewrite the domain and range. So the domain is the x's, so come up with some type of strategy to highlight the x's. So smallest goes first, so negative 2, then negative 1, 6, 7, 8. And then my range, smallest to biggest, 1, 4, 5, 6, and then 9. Make sure I got them all. 1, 4, 5, 6, 9. Okay. So that's all they asked you to do. For this one, this is a level 4 type question. Some students are doing really well with this. It says draw a graph that has a domain of negative 4, 3. Remember, these are talking about both domains, and then this is talking about your range of negative 2 and your range of 8. You have a parenthesis here, so you want to match up the range with the parenthesis. Remember, when you write your ordered pairs, you do x comma y. So you want to do negative 4 comma 8. Now the parenthesis in interval notation means it's going to be an open dot. Then you have to ask yourself, okay, what's my domain for the bracket? What's my range for the bracket? So my domain is 3, and my range is negative 2. But notice that I said bracket, and there's a bracket written. What that means is there's a closed dot. So then negative 4 comma 8 is an open dot. And then 3, negative 2 is a closed dot. Now a question that came up today was, do we have to connect it? Yes, please do. Because that will give us the whole graph. You can check your answer by how far left does my graph go? My graph goes negative 4 to the left. How far right does my graph go? It goes 3 to the right. How far down does my graph go? It goes negative 2. And how far up does my graph go? It goes 8. So I know I did that correctly. All right. Number 9. Once again, you want to try your hardest to color code. The color pencils are still on the desk for you. Domain is your left to right. Your range is down to up. So how far left are you going? How far right are you going? How far down are you going? How far up? So please shade. So this graph, what is its width? How far does it go? Okay, it stops there, so I'm going to backtrack. How far right? Now, what is this x and what is this x? This is negative 1.5, and it's a bracket because it was a closed point. Now, how far right did I go? I went 1.5. Now you do the same thing. How low does my graph go? What's the smallest point? It goes all the way to level -1. How high does my graph go? Goes all the way to a level 1. So my interval for domain is from left to right, negative 1.5 to 1.5. And then the range is -1 to 1. Now for the same thing that we did for number 9, you do for number 10. How far left does this graph go? It doesn't just go to -5, it goes to -6. How far right does it go? Doesn't stop at 7, it actually stops at 8. So -6, bracket because it's a closed dot, +8 because it's a closed dot. Now how low does my graph go? It stops on level -7. Bracket because it's included on the line. How high does it go? It stops at the level 4. It's also a bracket because it's included in the line. Now for number 11, you do the same thing. You ask yourself how far left. Now a lot of you are like, oh, it's almost -3. But look at this arrow. This arrow means it goes on forever. If you extend the line out, it's never going to stop, and the domain is going to follow it. Here, it's never going to stop going to the right. The domain's going to follow it. So we call that -infinity to infinity. Now, how far low does my graph go? It goes to about the level -3. It's included in the line, so it's a bracket. How far up does my graph go? My range will always be included, so it's going to +infinity. For number 12, you do the same. How far left does my graph go? How far right does my graph go? It went -5, but it was an open dot, so I use parentheses. And then it goes to 4. It's a closed dot, so it's a bracket. How low does my graph go? It goes down to the level of -2. Once again, open dot. How high does my graph go? Goes to a 3 because it's closed dot. Now, for this learning target, it says, I can determine whether a relation is a function or not using mapping diagram, graph, table, or list of ordered pairs. So determining if something's a function. If given a graph, you just do the vertical line test. So my vertical line test, it only goes through one point. It only goes through one point. But I'm looking for a better answer than it passed the VLT. So it's a function because every x value, so x, when x is 1, it's only 0. When x is like 2.5, it's -6. So each x only has one y because each x Now for a table, you want to see the x values. You want to see, we have a x that's -4, but we also have an x that's -4. Notice that the x here goes with 5 and the x there goes with 25. That can't happen because every x has to have only one y. In this case, it has 2. So once again, be specific. It's not a function. Because the x of -4 has 2 y values. So do the vertical line test again because I gave you a graph. Right here, it's not a function because of these 2 x values. I'm sorry, the one x value has 2 y's. So this is not a function. Because x of -1, 2, 3, 4, x of -4 has 2 y values. Now when given a mapping diagram, you want to act like you're going to cover up the range because we only care about the domain. So this has 1, this has 1, this has 1, this has 1, this has 1. So notice that each x only has 1 y, so it makes it a function. Now the reason why I asked you to cover this up is because some students that don't cover it up see, well, I have 2 x's with 1 range, so that means it's not a function. That's not correct. You don't care about the ranges. You only care about the x's. Now for number 17, you do the same thing as if it was a table. You look at the x's. You see my x of 0 has 2 different y values, so it's not a function. Because x of 0 has 2 y values. All right, here we have a 0, we have an 8, we have a 2, and then we have a 12. So those don't repeat, so it is a function. Now in the last learning target, it says I can determine all solutions that make an equation true. So what we're looking for, I gave you a table of values, your x and then your y value. To make a solution, it needs to be a true statement. If you get a false, it means it's not a solution. So I have the equation y equals -5x plus 10. I gave it to you. These are all of our x's, so we're going to plug it into our x. And then we have all of our y's, or h of x's. We're going to plug them in there. So we have our 0, we have our 15, we have our -20, our -5, and our 0. Now just a reminder, these are all my y's. And I'm going to plug in my x's. So then let's just do this problem. -5 times -2 is 10. 10 plus 10 is 20. Is 20 the same answer as 0? No, it's a false. So it's not a solution. So I'm going to plug in -1. That's where that comes from. 5 times negative 1 is 5. 5 plus 10 is 15. Does 15 get me that 15? Yes. Negative 5 times 0 is 0 plus 10 gets you 10. Does not get you 20. So that's a no. This gets you a positive 5. 5 and negative 5 are not the same number. Okay, in my original video, I made a very common mistake. I plugged in the y value too many times. So the y value is 0, and then your x value is 2. So then you plug in 2 there, and then plus 10. You do order of operations, which is negative 5 times 2, which gets you negative 10 plus 10, which gets you 0. Notice that the 0 matches up with this 0, so it's actually a true statement, which means yes, it's part of the solution. For number 20 and 21, it says list 3 solutions. If you looked in your notes, it said a solution is an ordered pair that belongs on a line. So if you give me 3 ordered pairs that belong on this line, that's all I'm asking for. So I'm going to pick this point, and this point. So this is 1, 2, 3, 4. So this is 0, 6. Sorry, 0, 5. This is 2, 1. Sorry, 2, 2. And this is 4, negative 3. So you can pick other ones, but I just picked those 3. And then you do the same thing for this graph. So this is 1, negative 5. This is 2, negative 3. And then this is 3, negative 1. Those are all solutions. For 22 and 23, just like the page in our notes as well, x is negative 2, our y is 6. So plug it in. 6 equals negative 3 parentheses negative 2. So 6 equals 6. Since I got a true statement, yes, negative 2, 6 is a solution. Because I got a true statement. Okay, and another mistake that I made, you have to be careful. This is x, y. So the negative 2 goes into the y, and then the 5 goes into the x value. So then 2 times 5 is 10, take away 8. Remember, we're still trying to figure out if it's a true or false statement. So 10 minus 8 is 2. Negative 2 does not equal 2. So that is still a false statement. So it's not a solution. Now, of course, that's not really a complete sentence. You would probably say it's not a solution because it's a false statement. But you get the point. 24 and 25, this is a level 4 question, coming up with your own solution. Easiest way to do this, pick an x. Any x. So I'm going to choose x equals 3. Plug it in. 2 parentheses 3 minus 5. 2 times 3 is 6 minus 5 equals 1. You just calculated your y value. So this ordered pair would be 3, 1. For number 25, if I wanted x to be 0, you plug in 0. Negative 7 times 0 is 0 plus 6. 0 plus 6 is 6. So the y is 6 when the x is 0.